Hello everyone, this is Miss Chelsea and today we'll be learning about the line of best fit and scatter plots. So what is the line of best fit? When analyzing a linear scatter plot, this is the line that moves through the middle of the points the closest. Slope is the steepness of a line, the rate of change or the rise over the run. To find it, we take the vertical displacement and divide by the horizontal displacement. Next, we have the y-intercept, which is the initial value of a situation or the starting point where the graph intersects the y-axis as a coordinate, 0, y. It will be very helpful if you remember your slope-intercept formula for a linear equation. Y equals mx plus b, where m is the slope and b is the y-intercept. Now that we've reviewed our vocabulary, let's get started. There are a few important things to keep note of as we begin. Scatter plots are usually used to display real-world data, which does not usually follow a perfect pattern. Mathematicians have decided that if there is a linear trend in the scatter plot, they can approximate the average of the points by drawing a line through the middle of the main trend. They do not consider outliers when drawing this line. An outlier is a point that is pretty far away from the rest of your points. After they identify a reasonable line for the data, they can calculate the slope and y-intercept of the line itself. They use the slope and y-intercept to write an equation that will help predict other things about the line. Let's learn how to identify the most accurate line of best fit in scatter plots. In example 1, the scatter plots below show data comparison of the age of a child and the cost of a birthday gift for that child. Which has the most accurate line of best fit? If you look at A, it's a little bit above most of the dots. And if you look at B, it's a little bit below most of the dots. Line C has about the same number of dots above and below the line. It also follows the same general trend as the dots, and the distances are about the same, so answer C is the best choice. The other two options are either too high or too low and seem to be trying to include the outliers. Notice how A is including these two outliers and B is including this one. Now I want you to pause the video and try these practice problems below. Here's number 1. Numbers 2 and 3 can be found on the next page. You should have gotten A for 1, B for 2, and D for 3. Now, let's try calculating a line of best fit. In example 2, we're going to write an equation in slope-intercept form for the line of best fit drawn on the scatter plot below. Step 1 is to identify the slope of the line while ignoring the points of the scatter plot and focusing only on the line itself. Looking at the line of best fit, you can make a point here at 0, 2 and another point here at 6, 6. The slope of the line is then the rise over the run. From 2 to 6 we rise 4, and then from 0 to 6 we run 6. So the slope is 4 over 6, which simplifies to 2 over 3. In step 2, we identify the y-intercept or b value of the line. This is where the line crosses the y-axis or where x equals 0. In this example, we cross the y-intercept at the point 0, 2, so b is 2. In step 3, we're going to write our equation in slope-intercept form, y equals mx plus b. So we're going to replace m with our slope and b with our y-intercept to get y equals 2/3 x plus 2. Now let's try another example. Which equation would be the most accurate line of best fit for the scatter plot below? If we estimate a line of best fit, we can see that the slope will be negative. That means we can eliminate answer choice B. We also see that we have a y-intercept close to 9, so our y-intercept or b value cannot be 0, and our answer choice C is also incorrect. Now we just have to decide if the slope is negative 1 over 1 or negative 1 over 2. It is closer to negative 1 over 2, so answer choice D is correct. Now I want you to pause the video and try the two practice problems below. On number 4, you should have gotten answer choice C, and on number 5, you should have gotten answer choice A. Now, let's go to the next page. Finally, we are going to learn how to interpret a line of best fit. In example 4, the scatter plot below shows data collected from 17 different people. It compares the number of years of higher education, aka years after high school, that they received, including trade schools, apprenticeships, and academic colleges. A line of best fit has been drawn for the data. First, we need to interpret the slope. Let's focus on the line itself. Find two exact coordinates that the line passes through in order to calculate the slope. I am going to pick the points 0, 20 and 4, 50, although 8, 80 would also work. Now the slope is rise over run. We are rising 30 and running 4, so we're going to do 30 divided by 4, which is 7.5. Use this number to describe the rate of change in the trend of the scatter plot. The slope tells us that there's an average salary increase of $7,500 for every year of education past high school. Notice how we took our slope and we put it in the context of the data and situation. Since 7.5 was the yearly salary increase in thousands, we multiplied 7.5 by 1,000 to get 7,500. The denominator here is 1, so it's for every 1 year. Now let's look at part B and interpret the y-intercept. First, you need to identify the y-intercept of the line itself. In this case, the y-intercept is the point 0, 20 because that's where we cross the y-axis. Use this number to describe the starting or beginning value of the situation. The y-intercept tells us that the average starting salary for a person with 0 years of education past high school is $20,000. Once again, we were very careful in including the situation that the data was calculated from. Finally, in part C, we're going to use the line of best fit to determine the average salary a person with 7 years of education might be predicted to receive. We need to find 7 years on the x-axis and follow it up to the line itself, not a point from the scatter plot that corresponds to 7. So 7 years looks like it's just above 70. Alternatively, we could use the 7 as x in our equation for the line of best fit. We know that our line of best fit has a slope of $7,500 and a y-intercept of $20,000. So we can plug our m and our b into slope-intercept form and get y equals 7,500 times x plus 20,000. We can then replace our x with 7 and do the math. 7,500 times 7 plus 20,000 will give us $72,500, which is a little bit above 70,000, just like we thought, but this is a lot more accurate number. Finally, let's write out our interpretation. According to the line of best fit, a person with 7 years of education past high school might expect to receive an average salary of approximately $72,500. Notice how when we interpret our data, we write our answers in complete sentences. Now that you've seen some examples of interpreting the line of best fit, I'd like you to do the two practice problems below. You should have gotten B for number 6 and D for number 7. Now go ahead and try the last page on your own.